Hello, everyone. So I guess we can get started. This is the INTAREA working group, IETF106. They're not well, as usual. As you know, we have to comply. This is an official IEEE meeting. So if you're not familiar, please take a look at it. We have a few references there, but it's pretty much about disclosing any knowledge of intellectual property that you could have. How about that? Okay, I'm just going to speak closer to the mic. So not well, if you're aware of any patent related to any of the topics we are going to discuss here, please mention it. And if you have doubts about the mode well, you have references here. As a reminder, the minutes are taking, blue sheets are going around. The meeting is being recorded. Your presence is logged. And the scribe, please contribute online minutes to Etherpad. Do we have someone that can help us take the minutes on the Etherpad? Please. It's a very light meeting today, so if anyone can help us with that, it'll be appreciated. Oh, thanks, Stuart. So thank you very much. How about Jabber? Can someone take care of Jabber, relaying the questions? Anyone? Thank you very much. Perfect. So we're good to go. So our agenda, as I said, is pretty light this time. The usual bashing of the agenda. We're going to have a presentation from Tommy about discovering provision domain names data and updates on that. The SOX protocol, Vlad will be presenting remotely. Probing IP interfaces by vendor-specific identifiers. Manoj, we are skipping that one, in fact. And SRv6 network programming, Pablo is going to present. Does anybody have any questions or comments on the agenda? Okay, good. So the status update, the discovering provisioning domains, names, and data, it's an IESG evaluation, but in fact, we're going to have a presentation in this meeting to discuss the topic in detail. So maybe you can ask Tommy directly for any updates. For the IP fragmentation considered fragile, it's an RFC editor queue. Apparently, that's just a reference issue, but that should be good to go soon. And the generic UDP encapsulation, it's an IESG evaluation right now. Okay. So if there are no questions, let me... So the next in line is Tommy.
Does it work? Good afternoon, everyone. I'm Tommy, and I'll be presenting our update on the provisioning domain document. So this has already gone through last call, but we have done some changes during the last call review, so I wanted to make sure that everyone was aware of that. All right, so last call was concluded. Our shepherd, Eric Klein, did a lot of good review, catching some nits in there, so we really appreciate that. Thank you to him for that. We've done several refinements during that process, so we're now on version 08. So we jumped a couple as we fixed typos and stuff. So I think it's in pretty good shape at this point. First, I want to highlight a couple of the minor changes that we did. These are a little bit more than editorial, but I believe they're still in the spirit of things that we intended all along. They were just not explicitly stated. First, we clarified that the multi-homing that we are offering with having multiple provisioning domains is only available to the PVD-aware clients. This should have essentially no impact on legacy clients, and they will not be aware of this multi-homing setup. We also clarified that the RA messages are intended to go separately to PVD-aware hosts and non-PVD-aware hosts. When that's the case, they should be using different LLAs so that these are easily separable. And lastly, we updated some of the text in the IANA considerations to be a bit more formal for our registration of the well-known URI format for accessing the extended PVD information. So that kind of brings those things up to speed. There is the one bit that we talked about last time that was one of, I think, the more open questions that we were still trying to work over. When we presented this in Montreal, we had 3 different options for how we were going to try to align the DHCP v6 information with the PVD information. During the process of getting that review, we kind of landed on something that was slightly different from what we presented there. So I did want to explain it to everyone here, make sure that we all believe it's the right thing, since this is kind of, during last call, post last call. So the key thing here is that we have separate recommendations about stateless versus stateful DHCP v6 elements. So the stateless elements, DNS info, other things like that, are associated with the PVDs that were received on the same interface that have the O flag set in the RA. And the stateful elements are associated with the PVD that has the M flag set in the RA, where the PIO includes the DHCP-v6 IANA. And so we're doing that match there. And for any cases in which there isn't a match, the DHCP-v6 elements are associated with the implicit PVD on that interface. So we think this is kind of the most sane way of arranging everything. Again, this is not something that we imagine is going to be like a huge use case of transmitting this information. It's more to ensure that if this information is received by the network, that the clients have something sensible to do with how they interpret and associate the data. So if you have any comments or concerns on that, please do let us know. So that's about it. That's what changed in the last couple updates. So again, thank you for all your input. So right now, it needs to go through IASG review, IETF last call. I think it's in AD evaluation. I wonder if Suresh can give an update on that. Those INTAREA ADs, man.
Yeah, Suresh Krishnan. So yes, I finished my AD eval. I was telling Eric, I just didn't have a chance to write it up. I finished it last week.
Oh, thank you.
But there's another draft ahead of this in the queue, which I haven't written up. So I wanted to get it out before the meeting. So I said hey, you guys are taking a long time, but I didn't. So I'll try to get it out as soon as possible.
Okay, so sometime in the next couple of weeks.
I would say if you don't get it by next Friday, something is seriously wrong.
Okay.
Check for my health.
Appreciate it so much. All right, and then just the other aspect of this is, now that this has been a fairly mature document, we have done previous hackathon work with this. We've done interop testing previously, but of course, a couple of the details have changed since then. So anyone who is interested in working on this, personally, I'm working on this for our Apple client side, but anyone who has a deployment that's interested in adding this support in and doing work at a hackathon in the upcoming times, please do reach out to the authors, and we would be happy to work on that with you. And that's it. Any questions? All right. Thank you all.
Thank you. Thanks, Tommy. So next in line is Vlad. Here he comes.
All right, hi there. So I'm going to talk about what we've been doing with SOX v6. So next slide, please. This newer draft is rather light. So we've got a mechanism whereby the proxy can provide a DNS service to its clients, and we've also added an option that can makes the proxy do happy eyeballs on the client's behalf. So next slide, please. So it was kind of obvious that clients needed DNS-like features. Non-SOX aware apps had to do A and quad A queries somehow. And in the case of happy eyeballs, those queries had to be done separately. Now, during the last IETF, someone's benchmark suggested that SOX clients should also be able to do ESNI, and currently you need to do TXT queries for that. And of course, there are some other DNS use cases that are cropping up. For example, service binding is on the horizon. Who knows if it will get standardized? And come to think of it, who knows what else will get standardized and what other future use cases there will be for DNS. So next slide. Up until draft 07, we used to have individual options for DNS-like functionality. So you could do A and quad A queries and also PTR queries. What was dangerous about this is that we were basically duplicating DNS functionality, and as new use cases, and if new use cases keep cropping up, then we're gonna have to keep up with them and yeah, basically follow whatever the DNS folks are doing. Now, obviously, the alternative is to have the client actually use DNS. However, of course, it can do DNS over SOX, but it's hard for the proxy to convey its policies. What IPs what resolver IPs it has to use, whether to do plain text DNS or DNS over TLS or DNS over HTTPS. DNS over TLS or over HTTPS might be associated with some credentials, and the proxy might have to give those credentials to the client. And in case of DNS over TLS, those credentials are actually private keys, so that's not going to work. And the alternative that we went for was to provide the DNS proxy. So next slide, please. So now, why shouldn't the proxy be a separate service, not related to SOX at all? I mean, the proxy could be running a SOX server on port 1080 and the DNS proxy on port 53. Next slide, please. Well, for example, if we're using Tor, the DNS proxy is going to be confused. I mean, which Tor circuit does the query pertain to? So if we have only one DNS proxy which lacks any kind of context related to the query, we're going to leak all of those DNS queries over the wrong relay. And if the client is trying to access something that is backed by a CDN, then the use of the CDN is going to be very suboptimal. So next slide, please. So the way we propose doing it is that clients simply make a connect request to 0.0.0.0 on port 53. That's not a valid IP address, obviously. And is presented with a plain text DNS service over TCP. The proxy also doesn't have to provide a valid bind address just in case it implements DNS on its own. Now, why are we doing TCP by default? Well, SOCKS and UDP is kind of hard for clients to implement. I mean, of course, it could be done over UDP, but by default, it's over TCP. The implementation was very trivial, so we simply installed DNS mask and translated 0.0.0 to port 53 to 127.0.0.1. That's it. There's nothing more to say about it. Next slide, please. So I'm gonna give you a quick and somewhat strawman primer on happy eyeballs. So you basically resolve and connect to a server using both IPv4 and IPv6. You do that in parallel and keep only one of the connections. This ostensibly offers failover from IPv6 to IPv4. So if a server does have a quad A entry, but the IPv6 endpoint isn't responding, then the IPv4 endpoint is going to be used instead. And of course, if one of the endpoints is faster, then the client is going to have better responsiveness. Now, clients have currently have all of the required features to implement happy eyeballs locally. So we've got DNS, we've got connect functionality, so it's not going to be a leap to implement the happy eyeballs mechanisms over SOCKS. Next slide, please. Now, there might be some cases in which it's appropriate for the proxy to perform the happy eyeballs mechanism rather than a client. So let's say we have high RTT between the client and the proxy, or the client and the proxy's vantage point. So happy eyeballs is gonna work like this. First, the client sends out two DNS requests, and one for A and one for quad A, and it gets back the response 1 RTT later. And then it issues two connect requests, one for IPv4 and one for IPv6. One of them fails for some reason, and the one that succeeds ends up generating a success reply from the proxy, and then the client can talk to the server. Next slide. Now, obviously, we're kind of wasting an RTT here. So SOCKS also allows you to use domain names in the request. So if the proxy can do happy eyeballs, then the client need only issue a connect request, and then the proxy sends out tries to establish multiple connections in parallel, and whichever of those succeeds ends up hooking the client with. This is obviously faster. We shave roughly one client to proxy RTT. So next slide. The way we do it, the way we currently do it is straightforward. So we have an option with no knobs that basically tells the proxy to do happy eyeballs. At the very minimum, the functionality that the proxy has to implement is failover from IPv6 to IPv4. The option semantics are the usual semantics used by SOCKS options. So if the proxy has no idea what to do with the option, I mean, it doesn't implement happy eyeballs, it simply ignores the option and doesn't echo it back. Otherwise, the client knows that the proxy attempted happy eyeballs. Now, of course, there's a caveat to using happy eyeballs nilly-willy. So if we use happy eyeballs in TFO, we're going to have a lot more replays than expected. So TFO does stipulate that replays can occur, but that's supposed to be a rare occurrence. Now, with happy eyeballs and TFO, there are going to be a lot of replays. And that's about it for me.
Thank you very much. Any questions for Vlad? There are questions.
Ben Schwartz. So first of all, I just want to say thanks for doing all the work here. This draft has improved in every iteration. I think it's really getting very good.
Thank you.
I do wonder about the happy eyeballs behavior here. I'm confused because in SOX 5, it seems like a proxy could already do this. So do you think that a proxy, do you believe that in SOX 5, the proxy actually already could be doing happy eyeballs?
I think it could. So the RFC was written 20 years ago, and it doesn't say anything about happy eyeballs.
Yeah, so that's my feeling as well. So my conclusion from your description here is that, in a sense, what you've really done is implemented an option to disable happy eyeballs. That's how I think about it. So one of my questions is, if you disable happy eyeballs, is there any reason to disable happy eyeballs other than TFO? The proxy already knows whether TFO is going to be used separately from this. So if TFO is not in play, is there a reason to not do happy eyeballs?
I don't really think so. I mean, there's no, aside from port knocking, there's no protocol that I know where just attempting to connect and then saying nothing means anything of value. So probably not.
So to me, that suggests that maybe we don't need this signal, and that maybe this decision could be implicit. For example, maybe we could say that the proxy just should do happy eyeballs unless it's in TFO, in which case it should do something like the retry.
All right. Okay.
Tommy Pauly, Apple. So yes, again, echoing Ben, thank you for doing the updates on this. And this is good discussion. I think going back to those diagrams you had, talking about the different approaches for how you use happy eyeballs, essentially, is it on the client or is it on the proxy? Totally agree that most of the time, it makes sense for this all to be on the proxy, and that's how we see it used generally today. I mean, there are going to be some cases in which the client does it, but those are going to be fairly rare. I agree with Ben that the explicit signal here is likely not needed. I think discussion in the text referring to happy eyeballs is important, saying that the proxy should use this mechanism when it is not a TFO connection, I think would be valuable, because that actually it gives more incentive for the clients to not try to second guess it on their own. But also indicating that, if you do have TFO in play, this is a concern, and in general, proxies should not do anything more than failover racing between addresses.
I mean, even failover could be problematic. So maybe the return path is faulty.
Fail all the way back to the client. And let them
Say again?
Or fail all the way back to the client and let them do it. Or not. It doesn't just don't do TFO on the second option. The second connection, you use TFO.
Well, I mean, if the client is providing a domain name as part of the request, then, and let's say that the proxy is biased towards using IPv6, the proxy sends out a TFO SYN, and let's say that the return path doesn't work. So then the client is left with a connection that isn't working. The proxy says, "Hey, that stuff didn't work."
Right, and so at that point, if you did receive an IPv4 address, you could simply do a normal TCP connection without TFO to the V4
Yes.
address and send the early data as non-early data, and that would still look the same to the client. It will just have a bit of extra overhead.
Yes, but that would also be a replay.
Okay, yeah. All right, so then I guess fail all the way back to the client.
Mhm.
So to Tommy, failing all the way back to the client is difficult here, because if the client just reissues the same connect to the same domain name, it will unless the proxy is actually stateful, remembers this, remembers to blacklist this. Unless the proxy remembers to blacklist v6 for that host, the proxy will just do the same thing again. If the proxy is stateless, the client reissues the same request.
Right. So one thing, actually, maybe this is some text we should add on the TFO case, because one thing to note is that TFO only sends early data when you do have a valid cookie for the server. So you must have gotten it at some point by talking to the server previously. Yeah, for TFO. Yeah. So in that case, it means you actually have previously established v6 connectivity to this host before. And so now if you essentially get an impairment later on, maybe we should just be very clear that we must have state about this server, because that's where the TFO cookies are stored. Maybe we should just flush that state if we realize that connections are failing to it.
That's true. That situation seems rare enough that a replay is okay.
Jonathan Lennox, I was going to say, sort of somewhat fortuitously leveraging off the previous thing, there's a lot of state related to happy eyeballs, and I think we need to at least analyze whether there are privacy implications for this. We want to make sure that this state isn't shared across various users of the proxy, but is, each user of the proxy has their own state, or you could find out what other people using the SOX proxy are connecting to, which would be bad.
Sure.
All right. So yeah. Well, I think the only state that's shared by clients are the TFO cookies. So those are per server rather than per client. Otherwise, I don't think there's any other shared state.
Tommy Pauly again. One thing to note, though, actually, with regards to this TFO conversation, if the client can detect essentially if TFO was successful because they got a really fast connection back, they will actually know if someone had previously connected to that particular address or to that server because the TFO cookie. So do we have privacy considerations that mention that?
Yeah, I should probably mention that. I didn't mention that.
I think that should be in there. Yeah.
Yeah, thanks, Vladimir. Suresh Krishnan. So just to put Gauri on the spot again, I kind of keep harping on this, but does TSV-WG need something specific from this one? Because I always feel uncomfortable just doing this here. So should we keep sending you notes every meeting, or how do you want to do this?
Hi, Gauri Fairhurst. Do I want more work? Wow, what a question. I think we probably would appreciate a presentation in TSVWG in our wonderfully packed agenda. We can make some space. If it tells us about the transport-related topics, I think that would actually be a really good thing. This is maturing, so it would be good just to get a presentation slot and do that. Would you be up for doing a talk in TSVWG?
All right, I think so, yes.
So in Vancouver, can you talk to the chairs a little bit ahead so we can make sure the content isn't a repeat of this, but is just focused on the transport stuff, and you'll get good feedback, I'm sure.
All right, sure.
Thank you, Vladimir. Thanks.
Thank you.
Great. Thank you very much. Thanks, Vlad. Great job.
See you.
So Okay. The next in line is Pablo.
Good afternoon. This is Pablo Camarillo, and I'm going to present on the Ethernet next header allocation that we are pursuing in draft IETF Spring SRv6 network programming. So the use case is pretty simple. In SRv6, we have a customer that is sending a packet. It arrives to the service provider network, and IngressP is just going to encapsulate this packet into an IPv6 header with an extension header that is going to be the segment routing header, as all of you know. This packet from the customer, it can be either an IPv4 packet, an IPv6 packet, or an Ethernet frame. And so what we are just doing here is allocating a new next header value in case that we have an Ethernet frame. So in previous revisions of this draft, what we were using is the IPv6 no next header value, 59. But during the last IETF in Montreal, there was some discussion about it, and the consensus from the 6-man Spring was actually to allocate a new code point for it. And so we had some discussions on which code point was allocated to, and it was for Ethernet. And that's it. So the processing for Ethernet is that is specified in the draft is just that the preamble and the frame check sequence are going to be stripped off when we are just doing the ingress encapsulation, and they are going to be placed back when we do the decapsulation. And just for you to know, the draft IETF Spring SRv6 network programming, it's actually requesting working group last call. But in the meantime, given that we have several implementations and deployments, we are requesting the early allocation for this value. So that's it. Any question?
Yeah, Suresh Krishnan. So the reason I wanted the SRv6 folks to come present here is there's like a protocol number allocation request coming in as an early allocation. So I just wanted the internet area to be aware of it. It's not that we are under severe scarcity in the protocol number space, and I really want them to not use 59 no next header to do this. So I'm inclined to grant it. So that's kind of why I just wanted everybody to be aware that this is going to happen.
I'll ask my question, Eric Klein. I'll ask my question that I asked you privately. I have not been following the network programming stuff, but is there a reason that 3378 Ether IP can't be used for your next header value?
So first, we do not have the Ether IP header in between the segment routing header and the egress Ethernet frame. And second, we are not following the procedures from that draft. In essence, based on segment routing, we are going to do, when we are going to decapsulate the Ethernet frame, we are going to do some processing and different kind of lookups based on segment routing. So we are not following the Ethernet over IP processing.
Commoners are Cisco systems. So also one of the reasons is this is a L2 VPN case. And today for L2 VPN encapsulation for a frame and an MPLS label packets, frame goes directly. Cannot hear? Oh, commoners are Cisco systems. Loud for you. So in MPLS case as well, we have L2 VPN where encapsulate incoming frame into label stack directly. There's no shim layer. For Ether over IP thing, we wanted to keep the similar for SRv6 based L2 VPN, where we have an IPv6 header and SRH header, as Pablo said, and L2 frame directly. We don't want to have any other shim layer in between, which is the Ethernet IP thing you were suggesting. Plus we have to be fully compliant if we were to do that with different Ethernet IP spec. The Ether IP drafts at 3378 defines the next header value for, say, everything after this is Ethernet. Does it not? That was my understanding.
Yes, but we need to have the Ethernet over IP header, which we do not have. And then it defines how we do the egress processing, which is not the same.
Oh, there's no Ethernet header.
Not the Ethernet header, the Ethernet over IP header, the 4 bytes of Ethernet over IP.
So then we will have an IPv6 header, then Ethernet IP header, and then frame. So this is a shim layer we're talking, like versus in MPLS, you have label stack. Yeah, I think we need a picture there. Yeah.
Thank you. Yeah, it's been clarified. Sorry, my fault.
Okay, and one more comment. As Pablo said, there are deployments which are actually in progress. So we are asking for actually also an early allocation of a code point that will have the deployments which are about to deploy this solution right now.
Okay. That's it. Thank you.
Thanks, Pablo. Okay, so if there are any more questions, that's it for this time. Thank you very much to everyone. Efficiency. Do you guys have the blue sheets somewhere that I can get them back? Blue sheets.